Hi, welcome to my video on extra problems number 6 on the unit on circles. And this video would have just one problem. A rectangle is inscribed in a circle. The perimeter is 56, the adjacent sides are 2x plus 2 and 3x plus 1. Find to the nearest square unit the area of one of the smallest segments of the circle. So it says a rectangle is inscribed in a circle. So let's draw a circle. And a rectangle is inscribed in a circle. Normally a rectangle has a length and a width. So I'm going to do this approximately. So it's inscribed in a circle. A rectangle has 4 right angles. And it has the opposite sides equal. Normally this is the length and this would be the width. And the adjacent sides are these two binomials. And we want the area of the smallest sector. The smallest segment. So since this is the longer side, this segment and this segment would be the same area. And this is the shorter side. So this segment and this one right here is the smallest sector, is one of them, because it's opposite the smaller chord. So let's find the length of the sides. So we have the perimeter is 2L plus 2W. So the perimeter is 56, and we'll say the length is 3x plus 1, and the width is 2x plus 2. And the reason I'm saying that, because if you take a 10, put a 10 here, you get a 31. If you put a 10 here, you get a 22. So this looks like it's going to be the length. So let's work it out. And we'll see. 6x plus 2, 4x plus 4. 56 is, that works out to be 6x, 4x adds up to 10x. 2 plus 4 is 6. So 10x is 56 minus 6. 10x is 50. Divide by 10, and x is 5. So if x is 5, let's look at 2x plus 2. So x is 5, so that means we have a side of 12, and we have 3x plus 1, and we have a 5 for x, so we sub that in. 15 plus 1 is 16. So we have the sides of 16 units and 12 units. So this is a 12 and this is a 16. So, as I said, this is the shorter chord, so this is the smaller segment here. And this is the other smaller segment, which is the same area as this one. This is the longer chord, so this is the larger sector. And this is the same length, opposite sides equal. So this is this segment here, and this segment have the same areas. Now, in order to find the area of the segment, we need the center of the circle, and we need a sector and a triangle. So we'll draw a diagonal. So in this diagonal, we have this triangle. Before I do that too, let's label the vertices A, B, C, D, so you know our triangle. So I'm dealing with the triangle. Let's go this way. Let's deal with the triangle A, B, C with the right angle, 16 and 12. So C squared equals A squared plus B squared, because we've got a right triangle. The hypotenuse we will call BC, and it's 16 squared plus 12 squared. So BC is 256, 12. This is B squared. 12 squared is 144. So B squared is 400. So we have BC is the square root of 400 plus or minus. So let's go up right here. So BC is plus or minus 20. So the number can't be negatives. They're dealing with geometry, so it's a 20. Now, what happens, that this diagonal is 20, but if I draw the AC diagonal here, note in a rectangle, the diagonals are equal. And not only are the diagonals equal, but the diagonals bisect each other. So if the diagonals are equal and they bisect each other, and this AC, did I say AC? Oh, that's a D there. Now see, I'm talking too much and not being careful. So BD. So BD is 20. So this is 20. So what happens, again, the two diagonals are equal and they bisect each other. So that means that they bisect each other and they're equal. So that makes it 10, 10, 10, and 10. And notice, because they're, let's call this O, because I'm going to say this is the center of the circle, because OB equals OC equals OA equals OB, and this is the circle, and these are equal distance from the center, equal distance from O, so O must be the center of this circle, where the diagonals of the rectangle intersect. So we have a triangle, and we have this triangle right here, so let me draw this triangle right here. Here it is. So this triangle is BCO, and we have a 10 and a 10. And what happens, that before I got a little bit ahead of myself here, I need to get what this angle is here. So this angle is X, angle OCB is X. This angle is X because this is an isosceles triangle, two sides equal, two angles equal. So I'm going to get the angle X first because we have a, and let me outline it this way. Again, I lettered it so we could see the triangles easy. Here's a right angle. This is 16 and this is 12, and I want to get this angle X. So to get the angle X, I could use the 20, or I could use the 16, 12 that I already have. So I could use the 20 if I want, because AC is 20. So I'm going to use the tan. The tan of X, tan is the opposite, which is 16 over adjacent, which is 12. So X equals tan to the -1 of 16 over 12. Now you can reduce 16 over 12 to a 4 over 3, but it's not going to make any difference, and you're going to get 53.1 to the nearest tenth. So this angle here is 53.1. And this angle right here is the same size, 53.1. So if you add all them up, you have, this is angle Y. Angle Y is 53.1, add on 53.1 plus, angle Y plus those is going to equal 180 in the triangle. So Y equals 180 minus 106.2 when you add these up. So Y is 73.8. And Y is the central angle. So this angle right here is 73.8. Now that we have a triangle and we have a sector, we can find the area of the segment. So the area of a sector, theta over 360 pi r squared, excuse me, and it's 73.8 over 360 times pi, and the radius is 10, and notice the distance, I put the radius as 10 here just to make sure, from here to here. OB, OC, OA, OD, they're all 10. So that's 10 squared. And you calculate that out, you get 64 point, let's say 4. That's to the nearest 10th. Now we'll do the area of the triangle. And the area of the triangle is a half. Now, it's A times B sine theta, but because we have two sides equal, they can say it's R squared sine theta. So it's a half. The radii is 10 squared sine of 73.8. And that comes out to be 48.01, etc. So it's roughly a 48. And so the area of the smallest segment is the sector minus the triangle. And that comes out roughly 16.4 square units. So there's a little bit of math working around, but you had to know that the diagonals are equal and they bisect each other, and making this point the center, the midpoint of the diagonals, the center of the circle, so we can have a triangle and a sector. So hopefully that video can help you further your understanding of math. Again, if you like my video, click the like button, click the subscribe button if you wish. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Just one word. Thank you for viewing my video. Hope the video was of some help to you. Bye-bye.